That is last one, non-terminating, non-recurring decimals. What those are? See, non-terminating, non-recurring decimals. So decimals are three types: terminating decimals, non-terminating recurring decimals, non-terminating non-recurring decimals. Okay, first these two we have completed. Third one we are going to discuss. So non-terminating non-recurring decimal, for that I will give one example. Suppose I am writing 2.131572671918 and so on. This means here in this decimal number, did you observe, is it terminating? No. Terminating means what it is, already I told you. Suppose if I write one number 2.13, just like 2.13. So now is it terminating or not? That is terminating, because here in this decimal number no number is repeating. And I didn't keep and so on, dots I didn't keep. That means that is terminating. Suppose one more I am writing 0.01567. So now is it terminating or non-terminating recurring or non-terminating non-recurring? First of all, is it terminating? Yes, that is terminating, because here no number is repeating and here I didn't keep and so on dots. So that's why this is terminating. Suppose 0.011111. So is it terminating? No, absolutely it is not terminating, because here the number 1 is repeating. So the number 1 is recurring. So this is which type of decimal? Recurring decimal, non-terminating recurring decimal. And these two are terminating decimals. Now here I wrote one decimal number. This decimal number, is it terminating? No, it is not terminating, because it is here, it has not ended. It has not ended. So now this is not terminating. And here, is it recurring decimal? Is it recurring? No, it is not recurring decimal. Did you observe any number is repeating here? No number is repeating. Just observe here. 1, 3, 1, 5, 7, 2, 6, 7, 1, 9, 1, 8 and so on is there. That means it has not ended. It has not ended. That means here this number, by observing we can say that this is not terminating and not recurring. Non-terminating, non-recurring. This is not terminated and not recurring. So that's why here any number, no number is repeating, any number is not repeating. So which type of decimal this is? Non-terminating, non-recurring. So what I wrote? NTNR. What is NTNR? Non-terminating, non-recurring decimal. Understood? So see one more example. I am writing 52.0607232233 and so on. Okay, is it terminating? Is it terminating? Terminating means like this. Already I wrote one example 2.13. So no number should be repeated, and here it should be ended. Is it? So terminating, is it terminating? 52.0607232333. Is it terminating? No. Is it recurring? Recurring means in this number any number is repeating? No number is repeating. By observing we can say that no number is repeating. Are you thinking 2, 3 is repeating? No. If you think 2, 3 is repeating, yes, here 2, 3, here 2, 3 is there, but here what number should be here? Here number 2, 3, again 2, 3 should be repeated. Is it or not? But here 2, 3 is there, 2, 3 is there, but here 3 is there. That means 2, 3 not repeating. Some numbers they will say that 2, 3 is repeating. No, so that's why this is a recurring decimal, but not. So here no number is repeating. So which type of decimal this is? Not terminating, not recurring. Non-terminating, non-recurring decimal. Understood? I hope you understood. Okay, so how many types of decimal forms we have? Terminating, non-terminating recurring, non-terminating, non-recurring. Okay now. So for these three, one example you see. Suppose here I wrote 2.1315. So that is terminating. Suppose 2.1315 bar. That is non-terminating recurring. Suppose 2.1315 some 2673 and so on. That is non-terminating, non-recurring. Did you observe what is the difference between these three? So here terminating, here two numbers are repeating, that's why we kept a bar above 15. Here no number is repeating and it has not ended. Did you understand? Okay. Now some more, we can see some more examples of non-terminating, non-recurring. So what are those examples? For non-terminating, non-recurring, what are the examples we have? See. Now, square root of 2. Square root of 2. Did you see these numbers anywhere? Yes. We are seeing in 8th class also. So now, this root 2 is non-terminating, non-recurring decimal. Why it is? So, to find the value of square root of 2, we have long division method. We have the method long division method. So, how it is? See. So, we are going to find root 2 value. Okay now. So, now, to find root 2 value, first we have to write 2. After, beside 2 right side, we have to keep point, decimal point and write zeros. Write zeros. And after writing zeros, you draw these lines, vertical lines, left side, right side, and to write zeros as pairs. Pair means 2. 2 zeros as pair, these 2 zeros as pair, these 2 zeros as pair. After that, here we have to see the perfect square nearest to 2. Perfect square. What is the perfect square nearest to 2? That number we have to identify. What it is? 1 square. So 1 square, 1 ones are 1. So did you understand? First number, what the number here we have 2. So what is the nearest perfect square of 2? Nearest perfect square. That means 1 square value. Perfect squares I am writing 1 square 1. 2 square 4. So in both of these, which is the nearest 1 4 in both of these, which is nearest to 2? 1. So that's why 1 into 1. 1 we have to write. So here 1 we have to write. Both 1 square is equal to 1. So after that subtraction, long division method this is. So that's why subtraction. 2 minus 1, 1. Okay. After that this one, for this one we have to add 1. Same number we have to add. So if you add, what you will get? 2. So 2 we have to write here. And after, so 2 zeros pair is there, so that pair we have to write here. We have to keep here decimal point because beside 2 we have the point. Now that point we have to keep here also. Okay. So now 2 is it. And after that, here which number if you write, those number also, here also we should write. Suppose here I am writing 2 and here also same number we have to copy. So here I am keeping box, see here. Suppose here I am writing 2. So here also we have to write 2. Then how to write this number? This 22 number we should multiply by 2. Then are you getting nearest to 100 or not? We have to check. Understood? Here and here same number we have to write. This 22 number we have to multiply by 2. And observe what you are getting, 44. 44 is nearest to 100? No. There is chance we can get more than 44. So that means erase 2. Take next number. Take next number. What is next number? 3. If you take 3, we are taking. So here I am taking 3, here also I am taking 3. So 23 multiply by 3. This 23 multiply by 3. What you will get? 9. 2 3 is 6. 69. So So 69 is nearest to 100. Maybe chance, there is a chance if you write 4, which number you are getting, just you observe. So I am taking 4. Okay, so this 24 multiply by 4. Which number are you getting? Just you once you check. 4. 4 4s are 16. 2 4s are 8. 9. 96. 96 also less than 200. If you take 5, what will happen? Just you observe. If you take 5, suppose, take 5 and we should multiply by 5 also. So 5 5s are 25, 2 5s are 10, 12, 125. Is it? 125 is more than 100. Is it or not? So now, which number I have to take? 4 or 5? 4 we should take, because 96 is nearest to 100, that is less than 100. We should not take 5 because 125 is more than 100. Did you understand? So now 4 we have to write. So here which number we have to write? 24 4s are 96. Understood? Now do subtraction. So what you will get? 4. 100 minus 96, 4. So now what is the next step? Here in the above step, what we did, same number we are adding. Okay, ones place number we have to add. Here in the 24, what is ones place number? In the ones place ones place, what the digit we have? 4. So we have to add 4. Add 24 plus 4. How much? 28. Did you understand? If you do 2-3 problems, you can understand easily. So this is the first problem. No? In the 9th class only we have this long division method for calculation of perfect square root of some numbers. So now 24 plus 4, 28. So now one pair we have taken already. So take second pair. Here one pair we have taken. Is it? Now take second pair here. So 2 zeros. Understood? Now, so here 28 is there. Here in this box again keep the box here and here. And in the boxes same number we have to write to get nearest to 400. To get the product nearest to 400. So which number will you guess? Check from 1 onwards you can check. No problem. So here and here take 1. Here also write 1. And check it. What the product you are getting. Now after that you can check by 2 also. Here write 2, here write 2. Okay. With 1, if you take 1, 281 and here also 1. No? By 1 we should multiply. What you will get? With product with 1 the product is 281. 281 we will get. Okay, 281 is less than 400. What you will get, just you check it. I am taking 2. Multiply 2 2s are 4, 8 2s are 16, 2 2s are 4, 5. 564 is more than 400 or not? So now, which number I have to take? 1 or 2? 1. 1 only we should take because this is more than 400. But here 400 we have, so 281 is less than 400. So that's why which number we have to take? 1. So here also 1. So 281 into 1, 281 and subtract. 10 minus 1, 9. 9 minus 8, 1. And here 3 minus 2, 1. 119, 119. Okay now. So come to next step. So now here also same method. Now ones digit we have to add. In the ones place 1 we have 1 added. So we got 2. Here ones place 4 we have. 4 is added. So then we get 28. Now here ones place what number we have? 1. So we have to add 1 to get next number. So add 1. So 1 plus 1 2, 28 as it is. 1 plus 1 2, 8 as it is, 2 as it is. Understood? Now one pair we have taken, second pair completed. Come to third pair. We have to write third pair, 2 zeros. So what is the next number we got? What is the next number we got? 11,900. Is it? Now, okay. Now here Here also same process. Keep here box, here also box. Which number if you write, you will get nearest to 11,900. Again here also same process. From 1 onwards we can check. If you write 1, here also write 1 and multiply and check. Write 2, here write 2, check it. Write 3, check it. So, I know the answer, no? So that's why I am writing direct what is the correct number. 4 is the correct number. Because square root of 2 value 1.414 and so on. Okay, we have to by heart these numbers. So that's why we can write directly. I mean process is same as usual we should write, but these numbers we can, if you remember, we can do easily. Okay now. So 4 is correct answer. So 2824 into 4. 2824 into 4. 4 4s are 16, 2 4s are 8, 9, 8 4s are 32, and 2 4s are 8, 3, 11. So 11,296. Subtract 10 minus 6, 4, 0, and 8 minus 2, 6. So 604 is the remainder. Okay, so here the division is not completed. This long division to find the square root is not completed. Still it is going on. Because here some remainder we got. Again we will keep 2 zeros. Again you will get some quotient. Again you will get some remainder. Again you will keep 2 zeros. So it is going on process. It is not ending. This decimal is not ending. That is infinite process. That is understood. So that's why if you doing like this, here also you will get some quotients. Okay. So that means by observing this whatever number here we got 1.414 and so on, by observing this decimal number, which type of decimal this is? Which type of decimal? Is it terminating? No. Is it recurring? Recurring means is it any number is repeating in this? No. So here this is not terminating and no number is repeating. So that's why which type of decimal this is? Non-terminating, non-recurring. This is the value of square root of 2. So to find the square root of 2, we have the method. Which method this is? This method is called long division method. By doing long division method, we got 1.414 and so on. If you observe, this is not terminating, not repeating. So NT-NR. So non-terminating, non-recurring. So square root of 2 is which type of decimal? NT-NR decimal. Not only square root of 2, we can by using this method we can find these values also. What those are? Root 3, square root of 3, and square root of 5, and square root of 7, square root of 8, and square root of 10, square root of 11, square root of 12. And we can find, by using this long division method, we can find all these values. Square root of 3, 1.732 and so on. That means this is NT-NR decimal, non-terminating, non-recurring decimal. This is 2.236 and so on. Like this, for every natural number we can find square root of. Understood? So now here in this class we have discussed terminating, non-terminating, recurring and non-terminating, non-recurring decimals. So terminating, non-terminating, recurring decimals, how to identify without division. How to identify? If you in the denominators, if you observe 2 power n or 5 power m or 2 power m into 5 power n form, if you observe in the denominator, then we can say that those are terminating decimals, or else non-terminating recurring decimals. Those two are only rational numbers. See here, these two types only rational numbers Q. Is it? What this is? This is not this is not rational number. Remember this. So only these two types of decimals only rational numbers. Which decimals are rational numbers? Terminating decimals and non-terminating recurring decimals. These two are only rational numbers. Is it? This third one, what we discussed today, the third one, NT-NR decimal, is not rational number. For those we have separate particular name. What it is? Irrational numbers. What it is? Irrational numbers. So all NT or decimals are called irrational numbers. Irrational numbers denoted by the letter Q dash. Irrational numbers denoted by the letter Q dash. So irrational numbers examples root 2 and 2.13152673 and so on. So like this we can give so many examples. By your own you can give. Understood? Okay. In the